A commonly misunderstood idea when we get to the Z transform section is how do we get from a continuous transfer function to a discrete transfer function? And there's a couple of different answers. So you have to keep your wits about you. In the datasheet, we have tables which relate the impulse response of a transfer function to the equivalent Z transform form. And so I'm going to work with a transfer function here which is in the table, in table 17.1 of Seaborg, which matches entry in the datasheet table. And if we just take a value like this and we do our substitutions, our normal substitutions, the Z transform, we can read off the datasheet table, and if we plot that, we see that the impulse response is exactly what we expect, just a exponential decay. The continuous transfer function impulse response is giving us the smooth curve, so that is actually this function over here, while the discrete values are giving us these dots. Now, just an aside, if you're looking for this, notebook, this is in the dynamics section of the notebooks. It's not in the control section. So that's all very clear. I think we basically have the Z transform that corresponds to the impulse response. But the value in table 11, in 17.11 is very different. It's clearly, it has more Zs, it's a lot more complicated, and so clearly we can see that that's not the same. So what's going on? These values are the Z transform of the transfer function with a hold element. And so we would write that Z of H times G. And after some manipulation, we find that what we're really trying to do, if we're trying to replicate those table values, is to look up in the datasheet table the corresponding Z transform of 1 over S times G of S. And if we follow along that logic, the element that corresponds in form to G over S in the datasheet table is this A over S times S plus A. If we copy that down from the table, we work through this, we can verify that we get exactly the same result as Seaborg's table 17.1. So basically, Seaborg's table 17.1 is just a simpler way, or a faster way, if you were doing this by hand, of obtaining exactly these same results. You can just do this using the datasheet. The datasheet has some more complex transfer functions than table 17.1. We can verify that this is the correct answer by, again, visualizing the analytic result. So this is now the same response that we get from the inverse Laplace transform, but now we are looking at a pulse response. And so we see that continuous line going up and then going down exponentially along with these points in time that correspond exactly. And so this gives us confidence that we have done exactly the right thing.